Chapter 3, Lesson 9, solving systems of equations with equations that are written in y equals mx plus b form. So we're using a substitution method in order to solve two systems of equations. As we learned earlier in this chapter, systems of equations are two or more equations that we're looking for the solution. So substitution. If you can see, 8 equals 10 minus 2. 8 also equals 5 plus 3. So if both of these equal 8, then we can technically substitute because this is true because both expressions are equal to 8. So 10 minus 2 equals 5 plus 3. That's the method that we're talking about today. We're substituting something in for something else. So in this first example, y equals 10x minus 2, but y also equals 5x plus 3. So therefore, this is true for the same reason, because both expressions are equal to y. So 10x minus 2 equals 5x plus 3. Okay? All right. So both equations are in y equals form. So the step one would be to set the expression equal to the other one. Variable, then you want to solve variables on both sides, and then to a basic two-step equation. And then, of course, check your work. So if y equals 2x plus 3 and y also equals 4x minus 7, then we have we can set them equal to each other. 2x plus 3 equals 4x minus 7. So now we have an equation set up with just one variable. And it's variables on both sides. So as we recall, we cancel out the smaller variable. So we want, and it's a positive 2x, so we want to subtract 2x from both sides. When we do that, we're left with positive 3 equals 2x minus 7. And now it's a basic two-step equation. So cancel out the subtraction by adding 7 to both sides. And when you do that, you end up with 2x equals 10. And then divide both sides by 2. And your solution is x equals 5. So we found our solution for x. Now we have to find our solution for y. Okay, so we have our original y equals 2x plus 3. We found x to be 5, so we replace x with 5. 2 times 5 plus 3 equals 13. So our solution then, of course, would be x equals 5 and y equals 13. And again, we write it in coordinate form. So x is 5 and y is 13. That's our solution. Okay, but as we keep, now we want to check to make sure that our work is correct. So all we do then is we just substitute into the other equation. So as long as it works in the other equation, we know that it works for both. So y equals 4x minus 7. 13 gets substituted in for y, and 5 gets substituted in for x. 4 times 5 is 20. 20 minus 7 does equal 13. They equal each other. It checks out. We know that our work is correct. Okay, so let's try. As you can see here, we have them set again. A equals 9c plus 20, and a equals c minus 4. So again, we set them equal to each other. 9c plus 20 equals c minus 4. This 1c is the smaller variable, so we want to cancel out that variable by subtracting a c from both sides. Leaves us with 8c plus 20 equals negative 4. Then it's just a basic two-step equation. Cancel out adding 20 by subtracting 20 from both sides. Negative 4 minus 20 equals negative 24. And then we want to cancel out our multiplication by dividing both sides by 8. Negative 24 divided by 8 equals negative 3. And then we want to substitute our C back into one of the equations to find A. Well, A equals C minus 4. So we replace C with negative 3. Negative 3 minus 4 equals negative 7. So our solution would be negative 3, negative 7, that coordinate. Now, again, and you always want to check your work. Okay, so we use this equation to find C, to find A. So now we're going to use this equation to check our work. So A equals 9 times C plus 20. We said that A equals negative 3. And no, I'm sorry, that's wrong. We said that Y, technically Y is the same thing as A in this case. So negative 7 equals 9 times negative 3 plus 20. Negative 7 equals negative 27 plus 20. Negative 7 equals negative 27 plus 20 equals negative 7. They equal each other. It checks, so it works out. Okay, so all we're really doing is just setting each of the two equations equal to each other because they are both equal to our variable. In this case, the Y value. Okay, so same one here. F equals negative 2G plus 6 and F equals 3G minus 34. Again, they're both equal to F, so we set them equal to each other. Now, one thing that I should have done in the previous slide, but I didn't, we should assign our variables to X and Y. So F is equivalent to our Y term in our formula for our equation, Y equals MX plus B. Okay, and in this case, G is equal to our X term. Okay, so all that means is that our X and our Y coordinate is equal to, in this case, G and F. That's all that means. Just want to clarify that. So set the two equations equal to each other. Negative 2G plus 6 is equal to 3G minus 34. And again, now we have variables on both sides. Cancel out the smaller variable. Well, negative 2G, okay, is smaller than 3G. So what's the opposite of negative is to add 2G to both sides. You end up with 6 equals 5G. 5 times G minus 34. Now it's a basic two-step equation. Add 34 to both sides, you end up with 5 times G equals 40. And then cancel out the multiplication by dividing both sides by 5. G ends up equaling 8. Okay, and then we just substitute in our G to find the other variable. So F equals 3G minus 34. Well, 3 times, we substitute 8 in for G. 3 times 8 is 24. 24 minus 34 equals negative 10. So our solution would then be the coordinate 8, negative 10. Okay. All right. So now let's try another example here. If you'd like, you can pause the video right now and try this one yourself, and then check back in and see if you did it correctly. Okay, so we have 4x minus 9 equals x minus 3. Okay, so once again, we want to cancel out the smaller variable. So we're going to subtract 1x from both sides. Leaves us with 3x minus 9 equals negative 3. And now we have a basic two-step equation. Cancel out the subtraction by adding 9 to both sides. Leaves us with 3x equals positive 6. Cancel out the multiplication by dividing both sides by 3. That cancels out. X equals positive 2. So we're going to use the first equation this time to find our y term. Y equals 4x minus 9. We're going to substitute in for our x what we found it with 2. 4 times 2 is 8. So y equals 8 minus 9, which equals -1. So our solution would be the coordinate 2, -1. Okay? And if you wanted to check it, which you always should check your work just to be on the safe side, use the other equation, y equals x minus 3. So y is -1, x is 2, 2 minus 3 does equal -1, so it checks out. We know that our work is correct. So here's a little challenge question for you. Go ahead, pause your video, and then you can attempt this challenge problem. Do the best you can, and we'll see what happens. Okay, so after you've tried this, they're still equal to y, so we're going to set them equal to each other. -3/2 x plus 4 equals 5x minus 9. So the first thing I would do is convert this fraction into a decimal because it would work out easily. -3/2 would be equal to -1.5 x plus 4 equals 5x minus 9. Just makes it easier to check. Okay. And then I would get rid of the smaller variable. So I would add 1.5x to both sides. Again, making sure that you line up your decimals. Okay, that cancels. 4 equals 6.5x minus 9. Then we want to cancel out the subtraction because it's a basic two-step equation. So we're going to add 9 to both sides. 6.5 times x equals 13. Cancel out the multiplication by dividing both sides by 6.5. X equals positive 2. Okay. So we found x to equal 2, and now we're going to use this equation to substitute it back in. So y equals 5x minus 9. Substitute 2 in for x. 5 times 2 is 10. 10 minus 9, y equals 1. So our solution is the coordinate x equals 2, y equals 1. Hopefully you guys got that right. If you didn't, hopefully you see where you might have made your mistake. All right, so that brings us to our exit ticket for this lesson. As always, thank you very much for watching our video, and we will see you in class. Have a good day.